Okay, طلبة الصيدلة, pharmacy students, Assalamu alaikum again. We carry on with our lectures in analytical chemistry as we have been instructed by the university to carry on with the lectures for the students until we cover as much as possible of the syllabus. I believe we've been up to titration reactions, and we did last time dilution as far as I remember. So what we mean by titration reactions, for example, acid-base reactions, I believe you know what's the meaning of acid, and suppose you know what's the meaning of base. In general, let us say acids are chemicals giving hydrogen ion in the solution, sorry, and base giving hydroxide ion in the solution. But in general, it's not necessary that acid to give hydrogen ion and base giving hydroxide ion. There's different types of acids and different types of bases, and this is not our topic for today. But in this subject with acid-base titration, we talking about titration between acid and base. So what we're saying here, we're saying for all chemical reactions, any chemical reaction, when you write a chemical equation, balanced chemical equation gives the mole ratios of reactants and products. For example, when you write any equations like, for example, just 1 minute, if you help me. Can we go to the board? If we write like H2, for example, I'm going to take this simple example, plus O2, this writing, does the job anyway, to gives water. That's a very simple equation, just to explain what I meant by the ratio. That's 2, of course. That's O. Right, so if we take this equation for reaction of hydrogen with oxygen to form water molecules, if we look at the equation, we're saying 2H2, and 1O2 giving 2H2O. What this 2 means, and this 2 means, of course, this is 1. This means like mole ratio. It means 2 mole of hydrogen can react with 1 mole of oxygen to make 2 moles of water molecule. So the ratio of hydrogen to oxygen is 2 to 1. So you need for each 1 mole of oxygen, you need 2 mole of hydrogen to make 2 mole of water molecules. That's the meaning. Okay? Right. Let's go back to the our lectures. I mean our document, the PDF document. Just 1 minute. Right. So if we are dealing with pure chemicals, the molar mass allows us to convert the mass of a reactant or product into moles. I think we did this before, and you might remember how to convert. It's very important to know in analytical chemistry well, in general, in chemistry, you need to know that how to convert mole to mass or mass to mole. We did this lecture before, and as far as I remember, you did some examples in how to convert the mass. Of course, the unit for mass is in a gram. Usually we use a gram, and we convert it to number of moles by using the molar mass. If you remember the molar mass means what is the mass for 1 mole of that particles. Could be molecules, could be ions, could be atoms. So for example, the molar mass for oxygen gas is, how much can you remember? I'll give you a few seconds to remember. It's 32. One oxygen is 16. It means if you take oxygen molecules, be careful, I am saying oxygen molecules, I mean O2, not O. If you take 1 mole means one Avogadro's number. The mass for that 1 mole is 32 grams. So you have each mole, what mass is it? So by using molar mass, you can convert mass to mole, or you can convert mole to mass. However, when we are reacting solutions, we have to convert the volumes of the solution into moles of the solute. In this case, we talking about volume because we're talking about solution. This can only be done if the molarity of the solution is known. If you know the molarity of the solution, you can find out the number of moles, because molarity is number of moles per unit volume, So if you know the volume and you know the molarity, it means you can find out how many moles. Repeat, with solutions, if you have the volume and you know the molarity, so you know the molarity and you know the volume, it means you can find out the number of moles of that solute. As we have seen before, the number of moles of the solute, reactant, or product is N, given by N number of mole equal molarity times volume. Or in other words, if you rearrange this relation, molarity is again number of mole divided by volume. So if you want to find out the number of moles, you need two things to know. The first one is the molarity, and the second one is the volume. Right. So reactions such as acid-base reactions, adding a solution of one reactant, solution of the other reactant, until an indicator shows that just enough of the first reactant has been added to react completely with the second reactant is called titration. So what titration means, you have two solutions, you're mixing them. You have, for example, in solution 1 an acid, and you have in solution 2 a base. And of course, that acid will react with that base, in this case, when we do titration. And there is something like, let us call it equivalent to each other. In other words, how many moles of that acid will react with that base. So for example, if you have number of moles of acid and number of moles of base, but the number of moles of acid is greater than the base. So number of moles of acid will react with base, and the excess acid will be left in the solution because there is no base react with it. يعني بالعربي عدد من المولات من الحامض يتفاعل مع عدد المولات مكافئة مناسبة من القاعدة، نصل إلى نقطة، وهذه النقطة هي نقطة التعادل. يعني كل البيس يستهلك. إذا كان الأسيد إضافي فيستهلك قسم من الأسيد والإضافي يبقى، لأنه ماكو بيس يتفاعل معه. هذه النقطة اللي هي الإند بوينت، بمعنى إحنا راح نقدر نعرف عدد مولات القاعدة المكافئة إلى عدد مولات الحامض. How many moles of acid neutralized, let us say neutralized how many moles of base. طبعا when we do titration in the lab, what we doing exactly? We're dealing with volume to volume geometry. So titrations are usually volume to volume stoichiometry problems where a concentration is the unknown variable. لأنه إحنا من نسوي titration, when we do titration, our point is, our target is to find out the concentration. We don't know the concentration. That's the purpose of titration. Remember this point. Why are we doing titration? We're doing the titration to find out what's the molarity, what's the concentration of that solution. We have no idea about the concentration, so we need to find out the concentration of that solution. So how we can find out the concentration? By titration, acid with base, but we need to know the concentration either for the acid or for the base, one of them. We cannot do two unknown in one time. We should have one of them known and the other is unknown. So for example, if you know the molarity, I mean the concentration of the acid, you can find out the concentration of the base. Or if you know the concentration of the base, you can find out the concentration of the acid. In either cases, you can find out one, but the other one should be known. So one, known, one is unknown. So when we do titration, we take some volume of the unknown, usually something like 20 cubic centimeter, for example, or 25 cubic centimeter, something like that as example. And we will show you how to do that. But remember, this process, when you deal volume to volume, you're adding one solution to another solution to reach like something, let us say, end point or equivalent point between that acid and that base. That's called titration. A measured volume of one reactant of non-molarity, be careful here, measured volume, so we know the volume of one reactant of non-molarity. Let's highlight them for you. Measured volume, okay, and non-molarity, okay, is added to non-volume again of the other reactant. The end of the reaction is generally noted. And of course, we adding an indicator. يعني why we adding indicators? So how we know when we add acid to base or base to acid? We're doing that titration. So how can we know where's the end point, where that acid neutralized that base? I mean, all acid reacted with all that base in the solution. So we need something like to tell us, okay, stop here. That's the end point. I mean that all acid reacted with all that base. So we need to add something, give us an indication, something like change in color, for example, or change in pH, or change in conductivity, whatever. There is so many ways for indication. But by classical way, let us say indicators we use, like some chemicals we added to the solution. It gives, for example, certain color. At the end point, it gives different color. So from the change in the color, we can guess that we stop the addition of the acid to the base or the base to the acid. We stop there and we just measure how much volume we added. So we know the volume